So now let's have the example 2. Here is the problem. Sketch the graph of f of x equals to 2 raised to x, g of x equals to 3 raised to x, and h of x equals to 4 raised to x in one plane. Compare the three graphs and find the properties of these functions. So for the solution, first part, we need to construct a table of values of the ordered pairs for the given function. So we need to solve for the ordered pairs in order to have a table of values. So now, here is the solution. So first, our function, we have three functions in the problem. We have f of x, g of x, and h of x. So first, let's have f of x equals to 2 raised to x. So it's also the same function to our first example. So let's have a domain, which in this form of exponential function is a set of all real numbers. So since this function, exponential function, is in the form of f of x equals to b raised to x, wherein your b is your base. So let's have a negative value, which is negative 2. So let's have a domain from negative 2 to positive 2, since we have a set of real numbers. F of negative 2 is equals to 2 raised to negative 2. So we substitute the negative 2 to our x. So this is equals to 1 over 2 raised to 2. So this shows the law of negative exponent. So 1 over 2 squared, or 2 raised to 2, is equals to 1/4, 1 over 4. Next, let's have f of negative 1. So f of negative 1, we substitute negative 1 to our x. So we have 2 raised to negative 1. So 2 raised to negative 1 is the same as, is equals to 1 over 2 raised to 1, which is equals to 1/2. Let's have f of 0 equals to 2 raised to 0. Anything that any value that you raise or which has an exponent of 0 is equals to 1. F of 1 is equals to 2 raised to 1. So 2 raised to 1 is equals to positive 2. And let's have f of positive 2. We have 2 squared, or 2 raised to 2, which is equals to positive 4. So these are the range these are part of the range for our function, exponential function f of x. Now, let's have the second function, which is the g of x, equals to 3 raised to x. So same domain, let's have negative 2 to positive 2. So g of negative 2 is equals to 3 raised to negative 2. So 3 raised to negative 2 is equals to 1 over 3 squared, or 3 raised to 2. So this is equals to 1 over 9. So 3 squared is 9. That's why we have 9 here. 3 times 3 is 9. So g of negative 1 equals to 3 raised to negative 1. So this is equals to 1 over 3, or 1/3. G of 0, so we have equals to 3 raised to 0. That is equals to 1. So let's have g of positive 1. We have 3 raised to 1. So it's equals to 3. And last, we have g of 2. That is equals to 3 raised to 2 equals to positive 9. So again, 3 times 3 is positive 9. And last, let's have h equals to 4 raised to x. So this is also in the form of f of x equals to b raised to x. That's why our domain is set of all real numbers. So let's have negative 2 to positive 2 also. So h of negative 2, substitute negative 2 to our function 4 raised to x. We have equals to 4 raised to negative 2. So 4 raised to negative 2 is equals to 1 over 4 raised to 2. So it becomes positive because it's already in the denominator. This is again the law of negative exponent. So we have 1 over 4 squared, which is equals to 1, and then our 4 squared is equals to 16. So we have 1 over 16, or 1/16. Next, let's have h of negative 1. So h of negative 1 is equals to 4 raised to negative 1, which is equals to 1 over 4 raised to 1. Of course, this 4 raised to 1 is also equals to 4. So we have equals to 1/4. So now let's have h of 0. H of 0 equals to 4 raised to 0. Then that is also equals to 1. And we have h of positive 1. We have 4 raised to 1. That is equals to positive 4. And last, we have h of 2. That is equals to 4 squared. Because our exponent is 2 here. So 4 times 4, that is equals to 16. So here is the table of values. So we have the domain, set of real numbers, so from negative 2 to positive 2. And the range for our f of x, we have 1/4 for negative 2, 1/2 for negative 1, 0 for 1 for 0, 2 for 1, and 4 for 2. And for the g of x, we have 1 over 9, 1/3, 1, 3, and 9. And for h of x, we have 1 over 16, 1/4, 1, 4, and 16. So now, let's move to the second part of the solution. We need to plot the points on a Cartesian plane and connect them with a smooth curve. So we're going to use the table of values and plot those values in our Cartesian plane. So here is the table. So we have x as their domain for these three functions, and here are the range. So plotting these three functions, we can have these three curves of the graph. So for the f of x, we have this red smooth curve. So if we plot negative 2, comma, positive 1/4, we have this plot. We have this point. So for negative 1, we have this positive 1/2 to our y, and for 0, we have 1. For positive 1, we have positive 2, and for positive 2, we have positive 4 for our y. So that's it for f of x. And when we plot the g of x, the function g of x, we will have this smooth block curve. So we have negative 2, 1 over 9. So it's just like they coincide with the blue curve, but when we zoom this graph, we can see that those points are plotted. So when we plot positive 2 to x, we'll have positive 9 to our y. So for the h of x, we have this blue curve of the graph. So we have positive 1, 2, positive 4, and positive 2 with positive 16. So it's just continuous up until to positive infinity, since our domain is up to positive infinity. So here are the remarks and the characteristics of our graph, or the function, exponential function itself. So these three functions have a domain, which is the set of all real numbers. So just like what I've said in our first example, since your form is f of x equals to b raised to x, then your domain will be the set of all real numbers. For the range, so as we can see, these values of range for our f of x, g of x, and h of x are all positive real numbers. So we cannot see a value of negative here. So this is from 0 to positive infinity. And the y-intercept of the function equals to b raised to x is 1. So as we can see here in our graph, the y-intercept of these three curves, of these three graphs, is y is equals to 1. So we have this plot. They coincide at the y-axis at y is equals to 1. And the horizontal asymptote is y is equals to 0 rather. So meaning that this x-axis, that the three curves won't touch these three functions, these three graphs curve will approaches the x-axis, but it will never touches. So that is our horizontal asymptote. That's it for example number 2.